Good morning, everyone. How are you? My name is Jason Hansen, and I'm SlackX on Twitter. I'm currently a principal program manager at Microsoft, and I work on Azure Container Service. My journey with Microsoft started 2 months ago when I was acquired with the Deis team. So we've been focusing on building open source tools for Kubernetes. So before we get started, a quick show of hands. Who here is using Kubernetes today? In production? Good. We're getting closer. Who is currently using Helm, the package manager for Kubernetes? All right, I see a few hands. And who is currently using a CI/CD pipeline to deploy to production? Wow, awesome. All right, so perhaps I will be able to shed a little light on the Kubernetes side of the story and perhaps less the pipeline side. As I mentioned, Deis joined Microsoft a couple of months ago, and I couldn't be more happy to be at Microsoft today. There's a lot of really exciting and interesting things happening, and I get to continue working on open source software. 5 years ago, I don't think I would have ever said that that was a thing that would happen to me, but here we are. So as I mentioned, Deis has been building open source tools for Kubernetes. We want to focus on making it easier for developers to build their applications and deploy them into Kubernetes clusters. That has taken the shape of 4 projects that we have up here. In the upper left-hand corner, this is Deis Workflow. So if you know us from our platform ambitions in the past, Deis Workflow, Deis, the platform, used to be based on CoreOS and Fleet. About 2 years ago, as these new container orchestration systems were starting to arise, we did a bake-off. We used Docker Swarm, the legacy Swarm, Mesos and Marathon, and early Kubernetes. We integrated with these 3 orchestration systems and then gave the project to our community and said, hey, let's go kick the tires. Let's see how this works inside your organizations. Through that process, we chose to all in on Kubernetes and then spent the next 8 months porting from CoreOS and Fleet to 100% Kubernetes. So Workflow just needs the Kubernetes APIs, and once you throw that on top, you get a 12-factor application platform. So if you've used Heroku, you get that same Git push experience with Kubernetes being the engine. In the process of building a Workflow, we created Helm. So if anyone's used Kubernetes, you got your face melted by YAML. There's just YAML, copy and paste all day long. Our team had a hard time sort of dealing with the way that you describe applications, and we really felt that there was a need for a package management piece to sit on top of Kubernetes. So Helm was born at a company offsite. We were all drinking beers and decided that this would be a really good idea. This has caught the imagination of the Kubernetes ecosystem, and we couldn't be happier with the results. On the left, the little serving dish / bell. This is some forward-facing work that we're working on through the Kubernetes community to bring the Cloud Foundry Service Broker APIs into the Kubernetes space. And if you're going to be around for the meetup tonight, I'll be doing a demo of our service catalog work. On the upper right-hand corner, Draft is our most recent open source project, released a couple of weeks ago. And this is really around helping people get started with packaging and deploying their first application into Kubernetes. So I wanted to talk a little bit about the power of platforms as a service. We built Deis Workflow. It is that 12-factor application platform. Push your source code, we'll pick it up, we'll package it, deploy it into the cluster. The nice thing about the platforms generally are platforms are for people. They provide a standard interface, both for our applications and the way that our applications can find and discover each other, and the teams that are writing and deploying those applications. And generally, this provides a low barrier for developer onboarding. Easier to use, everyone wins. As well, these standard interfaces provide a set of out-of-the-box conventions. These conventions provide a consistent deployment experience, and overall, this consistency reduces the cognitive overhead for developers, which is generally great. Things shaped the same, you can have a set of expectations about them. But unfortunately, with those conventions come a set of limitations. Those limitations include new application patterns can flex the traditional platform models. So microservices, for example, we have a Cambrian explosion of apps. Slow adoption of emerging technology by platform providers can hinder, the cool new. Additional business requirements like governance and/or vendor net neutrality can bump into some of the capabilities of platforms. And then, of course, platform size and complexity itself can generally be a drawback. This has all been magnified in many ways through the rise of modern orchestration and container as a service platforms. We want more features, we want more capability, and we want it faster. So today I want to sort of deconstruct this platform as a service notion and figure out what are those human interfaces and what do we need to be effective. So I've got 3 goals roughly, and then I'm going to jump into demos, and we're going to play around here for the next little bit. So the first goal is a developer should stay in their environment. Hopefully we can reduce context switching there. Everything should be in source control, including the application, any application configuration, and of course the pipeline definitions themselves. One of the reasons to do this is if it's in source control, then that gives you a notion of visibility for your team, and you can also see what the heck just changed. And the third goal here is to let the capabilities of the underlying tools shine through. So we want to reduce the number of abstractions that are layered on top. And let's see where that takes us. So I've got 3 main ingredients for the recipe today. First is Helm, which is that application packaging mechanism for Kubernetes. Kubernetes itself does all the heavy lifting, and for my demos, I'm running them on Azure Container Service. And then I'm going to use Jenkins, which is the glue that screws everything together. So let's make a prayer to the demo gods and give this a go. All right. So our application, it's called Croc Hunter. This is, going to be the next big thing. Has anyone here hunted crocodile? Anyone? No? No show of hands? All right. So what our application does, it's a simple game. You drive a boat around and you shoot lasers at crocodiles. So this is our game. Pretty straightforward, right? Unfortunately, there have been some complaints about shooting crocodiles with lasers. So we're going to have to make some changes to this application. There also happen to be some bugs. The crocodiles have no impact on the boat. That's okay. So as a developer here, I'm on my laptop. I've got the source code. And yeah, so this is a simple Go application. And what we're going to do is we're going to go ahead and make a change, and we're going to make this game2.js, and we're going to check the diff here, and we're going to check out a dev branch. So I'm going to, let's see, gco dev. All right, I'm going to make that change again, but right on the right branch. All right, so we've made a change. And I'm going to go ahead and add this, and we're going to do new features. Now, so we've got the change. We're happy with it. And I'm going to go ahead and push this up. And what's going to happen here? I have configured Jenkins, and what you'll see in the upper right-hand corner is the Jenkins running in a Kubernetes cluster. And what we should see here, if I log in, I got my passphrase right the first time in front of a crowd of people. Nailed it. All right. So here we can see that the dev branch has noticed that I've pushed a change up to the GitHub repo, and we're automatically building this change. We're going to do 3 stages in our pipeline. The first is a compile and test. The second is a test deployment. And the third is a publish a container to a container registry. As I mentioned before, this Jenkins is running inside a Kubernetes cluster, and what you can see here is a pod that has been launched to run this pipeline. Now, one of the cool things about this is that these build environments are ephemeral, so we can specify what we want our build environment to look like, but it goes away once the test is done. So a lot of the pollution that you would normally get in your build environments isn't a problem. So here you can see we're jamming away. We're now building the Docker image, and we'll be pushing it to the build repo. So the question then becomes, so where did these build steps come from? How did Jenkins get a hold of this stuff? Well, what we've done here is configured the pipeline to read from the project, from the application repository itself. So we have a Jenkins file checked into the application repo. Here it's laying down that pod template, which is our build environment. And here you can see the set of steps. So we got some setup and some debugging stuff. And here you can see the compile and test stage, which builds the Go binary. We have a test to deploy. So in this case, we run a Helm lint to see if the deployment instructions are syntactically correct. And then we run a dry run to generate the final Kubernetes manifest to make sure that everything can compile down correctly. The third stage is to go ahead and publish this container to our container registry. So the cool part about that is that we now have an artifact that's been pushed to a container registry, and we can now reference that artifact either by giving the collection of charts to our coworker or colleague, or we could pull it back down onto our laptop. Now, this last step is something that's optional, and this will run when we do a merge to master, which will actually deploy this out into our environment. So we should see, the check marks are green. So this is great. What I'm going to do is I'm just going to go open a pull request, and we'll say, well, we've added some new features, and we've also configured a set of webhooks here. So we've got new features and show all checks, and in just a moment, Jenkins should push a build status. So now we're going to be building the PR with the code merged down, which would represent the SHA after our application has been built. So we go ahead and pop back over to our Jenkins instance here, and you can see that we now have the pull request building. So this will do just what we saw before, but now with the commit, the build result will be the merge commit. So while this is running in the background, I want to go ahead and pop over and talk a little bit about the Kubernetes environment. So I work on Azure Container Service, and what Azure Container Service does is it runs the three popular open source orchestration systems, so DCOS, Kubernetes, and Docker Swarm. With a few clicks in the Azure portal, we will provision a cluster in your own subscription and help you run and manage that environment. The goal here is to provide those open source APIs, so we have not done any proprietary extension of the platforms, only insofar as to stand the server resources up. All right, so now we'll go ahead and publish that container, and we should have a green build status. I lost there we go, show all the checks. All right, so let's go ahead and merge this pull request. And once again, we will start the whole process over again. So we are nothing if not efficient at every turn. So let's go back and take a look at the master branch. So now that we're building on master, you can see that our pipeline is subtly different. We have an additional step which will be deployed to Kubernetes itself. So what this will do is this will use Helm to run a Helm install and a Helm upgrade to do a rolling deploy of our application. We should see here on the right-hand side, this is our application running in Kubernetes. It consists of 3 pods because Croc Hunter has a lot of scaling requirements. It's a very busy application. We're making tons of money. We're going to get funded, and then I'll fly you all out to San Francisco when we can do fun San Francisco things. All right. So one more thing on the Jenkins instance itself, so while this is building. I've used Helm to install Jenkins. Where I got that Jenkins from is from the upstream Kubernetes charts repository. A community has really come up around Helm, which has been cool. We've got a bunch of folks who are building and packaging off-the-shelf open source software. And I just want to run through a chart in a little bit more detail so you can kind of see how this ends up working. Every Helm chart has a chart.yaml file. This is big enough. This is metadata around the package. Includes its name, the version of the application which is contained in the package, and some metadata. There's also a values.yaml file, and the values.yaml file represents a set of parameters or configuration that can go into our package. Now, these provide this values.yaml file provides a set of defaults. When we install a package, we can override any of these defaults, either through a command line invocation or through providing an additional YAML file which gets merged on top of the config. Now, in the templates folder, we have everything in here that ends in .yaml or .tpl as processed as part of the package. So one of the abstractions that Helm brings to the table here is that we can take a set of loosely coupled Kubernetes resources, treat them as a single logical entity, and we can install, uninstall, and configure these things as a set. So we'll go ahead and pop open this deployment, and here you can see it. YAML's always somewhere hiding around at the bend. But here's a Kubernetes deployment resource, and it's been templatized. So here you can see we've got a bunch of sort of handlebar-y, mustache-looking things. And we expand those values in the context of this, this deployment. So let's take a look here. I'm just going to do a Helm list, and this will show all of the packages that I've installed in my cluster. And here you can see I've got Service Catalog, I've got Croc Hunter, I've got Draft, and a bunch of bits and pieces. The cool part is once you do a package installation, you can get a handle on that collection, and you can install the package multiple times into your Kubernetes cluster. So while I've been jibber-jabbering, we have finished the deployment, and on the lower right-hand side, you can see that our Croc Hunter should be updated. All right, the network, there we go. That's all right. So let's go ahead and do a reload. We've got a new commit SHA, and let's see what the new feature is. Well, the boat still works. Are there crocodiles? Okay, so there we go. Now we're shooting fish. We're shooting fish at the crocodiles. We're feeding them rather than shooting them with lasers. So we've done use the Jenkins pipeline. We've encoded the deployment instructions in a Helm chart and the pipeline instructions in a Jenkins file, all inside the repo. Not too shabby. All right. Good morning again. All right. Should always have a nice lights come on at the end of the demo. That's exciting. I like that. It's almost like having a soundtrack to your life. All right, so the three goals that we had right here. Developers using their own tools. So we used Git, pull requests, and Jenkins pipelines. From a source control standpoint, we had everything in source control, the application, the chart, and the pipeline definition. And Jenkins provided the glue that screwed all of these pieces together. And we used Jenkins and PRs both as visibility, what's happening to my application. So, there's a lot of moving parts here. This is all great, but we often hear people ask, well, how do I get started? For that, we have the new tool, Draft. The next demo will be Draft. Draft is focused on taking an application and just its source code. We'll detect the language and framework, and Draft will help you scaffold out a Helm chart to deploy your application and a Docker file to build your app. And it helps bootstrap the new Kubernetes app. And it's also focused on the inner loop for developers. So as you're doing early iteration, getting either your application or your configuration just right, Draft is there to help. All right, so let's do a demo. Make this a little bigger. Okay, so what I've got here is I've got a simple web application. It's written in Go, because that's what we do now, and it's very cool. And what this does is just a simple web server. When I run draft create will run a set of detect scripts over my application and hear that it's detected that it is a Go application. It's telling you, hey, we're ready to sail. If we take a look at the file system, what has happened is we've copied in some scaffolding. So here you can see that we've got a Docker file. I'll actually pop this open here. We are using the on-build image for Golang multi-stage builds coming later. We've also copied in a draft.toml file, which is application configuration, so what namespace this app is going to be thrown into, and an automatically generated name. In this case, it's Volted Heron. I don't know what that is, but there you have it. And we've also copied in a chart. So just with the Jenkins install, we now have a basic chart for this application. Chart and values. We kind of expect things to look web application-y, so you get some basic Kubernetes resources here, including a deployment, an ingress resource, and a service. So that's pretty straightforward. Now, back on my laptop, when I run draft up, what draft will do is it's going to take the current working directory, the Docker file, and the Helm chart, and push those up to the server, where we will do our Docker build, and then use Helm under the covers to install this application into the Kubernetes cluster. And it might work. There we go. Come on. You can do it. Yes, you can. Streaming output, still really hard. That's really pokey today. All right, there we go. So now we're pushing to the container registry, and since I included an ingress resource, we've generated a host name automatically for it. And here you can see we are spinning up the processes over on the Kubernetes cluster in the default namespace. So now I get a 503. There we go. Hooray. You can bring the lights up again. So this is now powered by Draft. You'll notice as well that Draft is watching for local file system changes. So as we make updates to our application, say, let's make this powered by Kubernetes NetUse. It will notice that the file system has changed, and it will run this loop all over again. Right, so this allows, again, focusing on that developer inner loop. I'm tweaking, I'm messing around with, I'm getting my application to a known good state, at which point you would generally commit and make a pull request, and your CI pipeline would pick up and take this application over the finish line. So that's Draft. Pretty new. We haven't cut any stable releases yet, but we're really interested in getting this into people's hands, especially if you don't have any experience with Kubernetes. Feedback is super welcome. All right. So the demos actually went pretty quick, so we've got some extra time. Got some links. Thank you. For the Jenkins demo, you can set this up on your own. My coworker, Lockie Evanson, who's from Australia and may or may not be an official croc hunter, he built this out. So give it a spin. Helm, as I mentioned, and Draft. We all hang out in the Kubernetes Slack and Helm users and Draft users channels. So, drop in, say hello. And I'm happy to answer any questions if there are any.
Maybe, yeah.
Hello. From what I'm understanding, drafts allow you to containerize your application faster, but don't you feel like it will encourage people to ship things that they don't actually understand?
That is a unique possibility. But what we want to do is we want to get people started. They get that first sort of hit of dopamine. Sarah Novotny calls it the mean time to dopamine, and then we can learn later.
Yeah, and then you just got a proof of concept in production.
Hey man, Silicon Valley, let's do it.
Okay.
Yeah.
Une autre question? So we are going to stop. Thank you.
All right, thank you very much.